This is just a quick video to introduce the concept of direct variation. And direct variation refers to a few things. One of them is that with a direct variation you can create this equation that has your dependent variable, which we learned about last unit here, that's y, your independent variable here, that's x, and something called a constant of variation here, which is m. And usually we use y and x, but that can change depending on the problem. To find m, we use this formula y2 minus y1 over x2 minus x1, which will make a little bit more sense as we do examples. But basically x1, y1 is a point, and x2, y2 is a point on a graph or a table of values. And for direct variation specifically, you will always go through point 0, 0. This isn't the case for indirect variation, which we'll go on to next. In this unit, you'll see this sentence a lot, where something, for example, distance, varies directly with something else, for example, time. And what you have to remember with this sentence is that whatever comes first is always going to be the dependent variable, and whatever comes at the end of the sentence here is going to be the independent variable. So for example, x and y. Let's look at an example, and hopefully this will start to make a bit more sense as we actually use it. So the distance traveled by a car varies directly with time. So right away, we know that distance at the beginning is dependent, and time at the end of the sentence is independent. So it's sort of like time is our x and distance is our y, if you were to graph it, for example. The car travels 180 kilometers in 3 hours. Find the constant of variation, m. So at the beginning we talked about this formula here for constant of variation. We're going to go ahead and use that so that we can find m. So m equals y2 minus y1 over x2 minus x1. So before we can solve this, we need to find our 2 points. So x1, y1, because this is direct variation right here, we can just use 0, 0. So x1, y1 will just be 0, 0. And then x2, y2 we're going to get from the question. So x is always independent, so that's going to be time, which is 3 hours. And the y value here is always dependent, and that's going to be distance, which is 180 kilometers. Now we can actually sub in our values. So down here, m equals y2 minus y1. We worked out that our y2 is 180. Our y1 here is 0. Our x2 here is 3. And our x1 here is 0. So you'll get 180 minus 0 on the top, which is just 180. And 3 minus 0 on the bottom, which is just 3. And 180 divided by 3 is 60. So you can say, therefore, the constant of variation is 60.